Hi, in this tutorial we'll demonstrate how to practically train an object detection model, using dental health inspection as an example. With ANSTS, you have the flexibility to train the model using YOLO v10 if you choose to enable the function. Let's create a project called Dental and start the project. Once you're on the project, first you need to load the dental image dataset. ANSTS enables you to verify if the dataset is sufficient for training. If the dataset lacks label files or the files are in formats different from ANSTS, click Launch Labeling Tool. The Labeling Tool allows you to annotate and add descriptive labels to your dataset. Additionally, it will enable you to import label files from various formats such as YOLO, Pascal VOC, and JSON, thereby allowing the reuse of your original label information. Importing label files with ANSTS is simple. Just select Yes and choose your original label format from the drop-down list. Press Check Label and Map File Information, and then the software will verify and display the original information in the same dialog. Press OK to start the label conversion process. This will create a copy of the label files in ANS format for future use. After that, all your label information will be automatically populated in your dataset. You can review and make any adjustments if necessary. In cases where the dataset lacks label files, select No and press OK to start labeling. To label the object of interest, drag and drop the cursor around it. Then, enter the object name or select a name from the drop-down list if available. The labeling tool provides many functions to simplify your labeling process. After completing the labeling process, your dataset will be validated and ready to be sent for model training. Click Send Data to Engine to continue. To begin the model training, you need to set up some training parameters. ANSTS offers 4 distinct model types to represent the speed and accuracy of the output model. Choosing the suitable model type will depend on your application's requirements. However, the accurate type is highly recommended for its balance. The system will determine the batch size based on your GPU specifications. You can set as many training steps as necessary, as the training will stop automatically if it doesn't show any further improvement before reaching your specified step value. Once the parameter is set, click Start Training to begin the model training, and you can monitor the progress in the training log. During the training process, a portion of the data will be selected for the validation set, which will be used to test the model simultaneously. You can either allow the training to continue or stop it manually based on its performance during the training and validation progress. After completion, you can review the model training log in the Previous Experiments tab. From the selected experiment, you can review its training history. You also have the option to continue training the model if it can be improved by adding extra steps. Alternatively, you can create a new model from the New Experiment tab to try other model types or batch sizes. After the training, click Evaluate to review and select Models to export. By clicking on your desired model, you can optimize and export it for GPU and CPU inferencing. Once the model is exported, the software provides a built-in model testing interface. You can choose whether to test it. In the testing interface, you can choose from various image sources, such as image files or integrated camera streams, for AI inferencing. By returning to the previous page, you can export different model types and compare them in the model testing interface. The right panel will display inference information and provide options for result visualization. All exported models are zip files and can be utilized with other ANS deployment tools to create your applications. Thank you for watching.